How did electronics go from something expensive and inaccessible to something a kid can learn in a weekend? This is the story of 3 microcontroller revolutions: Arduino's accessibility, Espressif's connectivity, and Raspberry Pi's flexibility. How a billion-dollar company bought a piece of that maker movement, and why the 3rd revolution might be the last one that's truly open. In 2005, if you wanted to make a simple robot, you needed a $300 development board, proprietary software, and the ability to read datasheets hundreds of pages long written for electrical engineers. This wasn't a hobby, it was a career. At that time, Massimo Bonzi was teaching interaction design in Italy. His students, artists, designers, people who thought in sketches and prototypes, kept hitting the same wall. They had big ideas: sculptures that responded to touch, installations that reacted to sound, wearable devices that lit up when you moved. But turning those ideas into working prototypes meant learning embedded C, buying expensive tools, and deciphering documentation that assumed deep electronics backgrounds. They weren't trying to disrupt embedded systems, they just wanted their students to stop crying during office hours. So Arduino did something radical. They created an abstraction layer. Arduino didn't invent microcontrollers, they made them understandable. Instead of configuring registers in hexadecimal, you could write digital write 13 high. Instead of studying compiler flags and makefiles, you clicked upload. Instead of reading Atmel datasheets, you Googled Arduino Blink LED and found a tutorial written by a 14-year-old. That was a revolution, not the hardware, but hiding the complexity behind a language that made sense to normal humans. By 2008, companies like SparkFun and Adafruit weren't just selling Arduino, they were evangelizing it. They wrote tutorials, they designed shields, they hosted workshops. And by 2010, Arduino compatible wasn't a technical specification, it was a cultural movement. Art installations at Burning Man ran on Arduino. High school robotics teams switched from LEGO Mindstorms to Arduino. DIY drones, 3D printers, smart home devices, all with Arduino inside. By 2013, Arduino had sold over 700,000 official boards, which is all right, but 5 to 10 times that many clones existed. Factories in Shenzhen were stamping out Arduino knockoffs by the millions. And the Arduino team, they were fine with it, because Arduino was open source hardware. The Arduino revolution taught the world that electronics didn't have to be scary, but there was still something missing. The next revolution wouldn't be in a design school in Italy, but on the factory floors of Shenzhen. By 2014, Arduino had already won the hobby market, but it had one fatal flaw: no connectivity. Arduino's Wi-Fi shield cost $80 and barely worked. Cheaper modules were $50 and notoriously unreliable. Bluetooth? Same price and somehow even worse. The Internet of Things was a buzzword for products that normal people couldn't even afford to build. Then makers started tearing apart cheap Chinese security cameras. Inside, they kept finding the same weird little chip. It was the ESP8266. Look at this thing. The pin spacing isn't breadboard friendly. There's no USB port. If it looks like it escaped from a factory floor, that's because it kinda did. Teo Sui-an, engineer turned CEO of Espressif, had designed it for one purpose: add Wi-Fi to mass-produce appliances for under $2. Smart bulbs, cameras, rice cookers, anything that needed connectivity on a razor-thin margin. It had Wi-Fi built in, it cost $2, and nobody knew how to program it. Until someone leaked the SDK. GitHub exploded with reverse-engineered documentation. A few months later, someone had written an Arduino core for it. Suddenly, you could add Wi-Fi to any project for less than the cost of lunch. Now, Espressif could have shut this down, sent cease and desists, locked down their toolchain, but instead, they embraced it. They hired community developers, released official documentation. By the time ESP32 launched in 2016 with Bluetooth and dual cores, Espressif had done something remarkable. They'd beaten Western chipmakers at their own game by listening to hackers. Arduino made microcontrollers accessible. Espressif made them connected. But there was still a problem. You were locked into whoever made the chip. If you chose Arduino, you were stuck with Atmel's limitations. If you chose ESP32, you were betting on Espressif's roadmap. The platforms were open source, but the silicon underneath? That was controlled by chip companies. And in 2020, everyone was about to learn what that really meant. By 2021, Raspberry Pi had sold 40 million Linux boards, single-board computers powerful enough to run a desktop operating system. Eben Upton, the engineer who'd started the foundation to help kids learn programming, had built an empire around accessible computing. But they'd never made a microcontroller. That was Arduino's territory. That was Espressif's territory. And then COVID hit. Chip shortages made every microcontroller impossible to buy. Arduino Unos were selling on eBay for $60, if you could find them. Lead times stretched to 6 months. Product launches got canceled because nobody could source ESP32s. And Raspberry Pi did something shocking. They designed their own chip from scratch. The RP2040 wasn't trying to be faster, because it wasn't. It wasn't trying to be cheaper. At $1, it matched everyone else. But it was trying to be flexible. With programmable input-output blocks PIO, if you need HDMI output, program it. Need a custom serial protocol that doesn't exist yet? Program the PIO. You could make the hardware fit your project instead of the other way around. Arduino abstracted away the registers, Espressif built-in Wi-Fi. But you were still limited by what the chip manufacturer decided to include. The RP2040 asked, what if the chip could be whatever you needed? And that's the revolution. Within a year, everyone was using RP2040. Adafruit built dozens of boards around it. Pimeroni made it their standard. Even Arduino, they released RP2040 boards. The company that defined microcontroller boards was now using someone else's chip. The RP2040 didn't just compete with Arduino, it absorbed it. By 2021, Arduino was no longer a chip architecture. It was a software layer, an IDE, libraries, a way of programming that you could run on RP2040, ESP32, dozens of different chips. Arduino had become a meta platform. The hardware underneath didn't matter anymore. Arduino disrupted embedded systems. Espressif disrupted pricing. But Raspberry Pi proved that you don't need to be a chip giant to make competitive silicon, at least not for microcontrollers. That was 2021. Since then, the door's been closing. Chip design costs are rising. Fab access is consolidating. And that's got some very big companies nervous about who would control the next generation of hardware. Which brings us to 2025. Earlier this year, Qualcomm, the billion-dollar company that makes the chips in your smartphone, bought a controlling stake in Arduino. Not for the hardware, Arduino's revenue is tiny. Not for the patents, Arduino's open source. They bought it for something more valuable, the community. Qualcomm dominates mobile, but they're betting billions on industrial IoT. Smart factories, connected cities, the infrastructure layer of the future. There's just one problem. Engineers don't trust new platforms. They don't want to learn a proprietary toolchain that might be obsolete in 5 years. But they do trust Arduino. 20 years of tutorials, millions of developers, entire university curriculums built around it. Qualcomm bought 2 decades of trust and a ready-made developer base who already know how to use their chips. They didn't acquire a product. They acquired the on-ramp to future customers. And they're not alone. The semiconductor industry is consolidating. Microchip bought Atmel. Renesas keeps acquiring rivals. Even Espressif, still independent, faces pressure from investors to scale or sell. The maker movement succeeded by staying small, scrappy, and community-driven. But success brings capital, and capital wants control. This is how open source movements end. Not with a hostile takeover, but a friendly acquisition. Arduino's open source. The licenses haven't changed for now. But when your funding comes from a publicly traded company that needs quarterly earnings growth, how long before the priorities shift? How long before what's best for makers conflicts with what's best for shareholders? We've seen this story before. Android started open. Now try building a competitive phone without Google's proprietary services. Oracle bought MySQL, and the community forked it out of fear before the ink was even dry. Redis changed its license and got forked within weeks. Maybe Qualcomm will be different. Maybe it'll pour resources into Arduino, keep it independent, and never interfere with the community. It's possible. But history suggests when a billion-dollar company buys a scrappy open source project, something's gonna change. Massimo Bonzi didn't invent microcontrollers. He made them accessible. Teo Sui An didn't invent Wi-Fi. He made it affordable. Eben Upton didn't invent programmable I/O. He made it practical. Each revolution removed a different barrier. When I was growing up, none of this existed. The barriers to entry are lower now than they've ever been before. $5 boards, free software, tutorials in every language, AI that generates working code in seconds. The revolution that Arduino kicked off was never about Arduino itself. It was about the idea that hardware doesn't have to be gatekept, and it doesn't have to be hard. The next revolution? is only a matter of time. Thanks for watching, and I'll see you in the next one.